Okay guys, question 7. Now the key here for this one is the word light gate, these light gates here. You'll remember hopefully from determining gravity by free fall, dropping the card through the light gate. The way it works is the laser beam from the light gate gets broken as the card goes through it. So you can determine speed, okay, as speed is distance over time. So let's say V equals S over T. Basically what you need to know is you need to know the thickness of the card or the width of the card. Yeah, width, I can spell this word. Width of card and the time in the light gate. And that'll be in the light gate, and what they're looking for is G1, the first light gate there. Obviously it tells us after, so obviously width of the card, time light gate G1, and then you could say something like the velocity will be the distance, the width of the card divided by the time. That'll tell you the velocity. Trolleys A and B after collision, I think it says up here that they collide and sticks to. There you go, that's a magic word there, sticks to, so they're going to go through together, get G2. So after G2, it's only a 3-mark question, so you really need to say it's the time in G2. That's what the mark's for that one. They're going to assume you should really say the width again, but it's not likely to change. So 2 marks for that one, for these 2 points, width of the card and the time, and the 3rd mark is for the time in G2 when they both go through that together. How could you verify for part B that momentum is conserved in this collision? Well, indicating what other measurements would be required. Well, basically, at no point in this paper so far has anyone told you what momentum is. So the first thing you're going to need to do is you're going to basically need to tell them that you know what momentum is. That momentum is mass times by velocity. That's the first point, and that basically that's the first mark, that you understand what momentum is. And the second mark is for explaining that the mass of trolley A, if I put M of A times by V of A for the mass of trolley A times by the velocity of trolley A is equal to, it will be the mass of A plus the mass of B times by, oh, we should say rather A initial, okay, and V final, something along those lines. This is putting it in a mathematical form, but you just need to say, well, the momentum, the mass times by the velocity of trolley A should be equal to the combined mass of trolley A and B times by their new momentum at the end. But you can put it in words, you can put it, you're best to put it in words actually, because it says explain, so you put it in your own words, but that's really what you're going to say. So I'll let you write that how you want to, but that's what you're saying. C, explain, state and explain, 2 points. State and explain what you would do to minimise the effects of friction on the motion of the trolleys. Well, the best thing to do, you could have got a way of saying air track or lubricating the surface or other things to minimise friction, but the best thing to do is to incline the trolley, incline the surface. Okay, so if you incline the surface, then what happens is there, it's called a friction compensated slope. The component of the weight down the slope is then equal to friction, so there's no effect, so they cancel each other out. So you just basically put the thing on a very gentle slope. That's obviously a big slope, but a very gentle slope, so that if you give it a little push, it just keeps rolling at a constant speed, and it's called a friction compensated slope. Friction compensated slope, which is just you just angle the slope until it slows down. You've seen it, we've done it. Anyway, question 8, last question. Money for jam, this one really. Laptop has a charge of PD of 14.8 and a charge of that 15.5 times 10 to the 3. Negligible internal resistance. Calculate the maximum amount of energy the battery can deliver. Well, voltage, by definition, voltage is work done per unit charge. Okay, oops, it's Q, sorry. And there's for the work done, or the energy is voltage times by charge. So it's going to be 14.8 times 15.5 times 10 to the 3. So you can work that out and shove that in there. B, the average power consumption of the laptop is 30 watts. Estimate how long the laptop can be operated from the fully charged battery. So you're going to have this value here, which is of course your work, whatever that is. Let's say energy, W. Well, I'll just say energy. And energy is power times by time, as I think you know. So we want to say, well, the time is going to be T is going to be energy divided by power. So it's going to be this amount of energy here, whatever goes into there, divided by 30 watts. What that's going to do is give you the time in seconds, and that's the key thing. So that's why it's going to be a 2-mark question. So that'll give you the time in seconds, and then you've got to convert it into hours, and I think you know what to do there. You'll take that time in seconds, divide it by 3,600, and that'll give you the time in hours, and that's what you're going to shove into there. Okie dokie, that is the paper done.